Welcome to e-learning session. Myself Santanu Pathak, lecturer in food processing technology. Today we will discuss on unit operation of chemical engineering 1, unit 2. In this session we will discuss about the second part of thermodynamics. Already we have discussed about different terminologies and properties, functions which are related to thermodynamics. Now we will start different laws which are there in the field of thermodynamics. First, we'll start with Zeroth law of thermodynamics. Zeroth law of thermodynamics deals with the temperature. What is the statement of Zeroth law of thermodynamics? If two bodies are in thermal equilibrium with the third body, then they are also in thermal equilibrium with each other. That means consider three bodies A, B and C. The temperature of A is that is TA, temperature of the body B that is TB, and temperature for C is TC. Now A and C are in equilibrium and B and C are also in equilibrium. Then according to Zeroth law of thermodynamics, we can say TA and TB, that means A and B, those two bodies are also in equilibrium. That is the statement for Zeroth law of thermodynamics. It is very easy to understand. That means A and C are in equilibrium, B and C are also in equilibrium. That means we can say A and B are also in equilibrium. Example, consider two cups A and B with boiling water and take a thermometer, that is third body. Place the thermometer in cup A and allow the temperature of the thermometer to increase. It gets warmed up by the water until it reaches 100 degrees C. So now read the temperature as 100 degrees C and remove the thermometer from A and place it in B. Automatically it will continues to read at 100 degrees C because both are in at 100 degrees C. The thermometer is also in equilibrium with cup B. Earlier it was in equilibrium with cup A, and thermometer now it is in equilibrium with cup B. From keeping in mind Zeroth law of thermodynamics, we can conclude that the cup A and cup B are also in equilibrium with each other. Okay, understood? Here third body is the thermometer. Earlier, cup A and thermometer, that is the third body, will also in equilibrium. Then B, cup B and thermometer is in equilibrium. Now we can conclude cup A and cup B are in equilibrium. That is Zeroth law of thermodynamics. Now we will go gradually move to the first law of thermodynamics. Before moving to the first law of thermodynamics, we should know what is work, what is heat. Heat is the energy transferred from one object to another due to the change in temperature. Q equals to heat in joule, M equals to mass, C equals to specific heat capacity, and delta is the change in temperature. We can write Q equals to M into C into dt. Amount of heat change, that is Q equals to M into C into dt. What is work? The energy transferred when an object is moved against force. Work done equals to force into displacement, where W equals to force in joule, W equals to work in joule, F equals to force in Newton, and L is the distance in meter. Consider a system. Consider a system, cylinder, hollow cylinder, and in the cylinder there is a piston which is frictionless and weightless. If force is applied and displacement is dx, then work done equals to F into cos theta dx, where theta is the angle between force and displacement. So generally theta, the value of theta, it may be 0 or it may be 180 degrees. That means the direction of force and displacement is in the same direction. That means theta equals to 0, then cos theta will be 1, then order it will be F into cos theta into dx, cos theta equals to 1, so it will be F into dx or here dl. Or the force and displacement is in opposite direction. That means you are applying force in this direction and movement and displacement is happening at the reverse direction. That means angle between F and dx, that is equals to 180 degree. Cos 180 degree means minus 1. In that case, work done will be minus F into dx. Correct? This portion is clear. Now we can write expansion of W equals to minus P external into A as force equals to pressure into area. As we know, force per unit area that equals to pressure. So force equals to pressure into pressure exerted into area. So W equals to work done equals to P external into A into L. Here negative sign is there. Negative sign is there because we are considering that if, the direction of force and direction of replacement displacement, it is in reverse direction. That means theta equals to 180 degree. That's why the negative sign is there. Okay, so we have understood this thing. This is the work done. That means this work done is known as pressure volume work done. We will discuss little bit about the sign convention later also. So before going to the next topic, we should know the sign convention. Sign convention is very important, and don't be confused with so many things. We should follow the IUPAC convention. IUPAC convention, work done, if the work done by the system, that means that is negative. Work done on the system, that means work done by the surroundings, that is positive. Heat absorbed by the system, that is positive. Heat released by the system, that is negative. So this sign convention we should follow throughout the thermodynamics session. This is very important. Energy can be classified into two groups, that is accumulated energy and transitional energy. Accumulated energy means that, example, internal energy that cannot be extracted out. It will be there inside the matter, so it will not work. It will not function as work. So we will not get the output from the accumulated energy. Transition energy means heat, work, etc., which can be considered as performing work. Okay. So now we will understand what is internal energy. From the beginning, we are discussing about internal energy, internal energy, internal energy. Now we will understand what is internal energy. See, a system, generally a system consists of atoms, molecules, ions, and whenever these things will be there, there will be transitional energy, rotational energy, vibrational energy, electronic energy, nuclear energy, bond energy, magnetic energy, and due to these energies, there will be some total energy. So matter, matter, it consists of some threshold energy which is inbuilt within the material. So that energy is called internal energy. The absolute value of internal energy cannot be determined. Only the change of internal energy can be determined. Internal energy, it is an extensive property. That is, extensive property means mass dependent property. Change of internal energy, that is a state function. It depends upon the initial and final state only, not on the path. The value of internal energy increase with increase in T. Does not depend on the nature of the matter or certain condition. So now we'll see, it refers to the energy contained within the system. The internal energy of a system can be changed by heating of the system, working done on it, or by adding or taking away matter. So I already have discussed that is extensive property, that is mass dependent. See, again I have shown the change sign convention here. Energy inputs and outputs. See, work done on the system, that will be positive. Work done by the system, that is negative. Heat given out from the system, that is negative. Heat absorbed by the system, that is positive. So these are the sign convention, and keep it in very clearly in your mind whenever you are doing some numerical problem or you are doing some calculations. So this convention should be kept in mind. Now we will discuss about first law of thermodynamics. First law of thermodynamics basically deals with conservation of energy, heat and work, system and surroundings, internal energy. So these are the four concepts we will learn after learning the first law of thermodynamics. Now we should discuss the statement for first law of thermodynamics. The first law of thermodynamics, which is also known as the conservation of energy principle, states that energy can neither be created or destroyed, but it can be changed from one form to another. This law may be seem abstract, but if you look at the examples, the first law of thermodynamics, we will get a clearer picture or clearer idea. Let's have some example. Fans, fans are running by electrical energy, and whenever it is running, heat is produced. That means electrical energy is getting converted to mechanical energy. Plants convert radiant energy of sunlight to chemical energy during the photolysis. Okay, so these are the examples. Apart from this, so many examples are there. So you can you can write any example regarding this. So far, I have discussed about the statement of first law of thermodynamics. Now we will go for the mathematical expression for the first law of thermodynamics. See, consider a matter at state 1. Consider a matter which is in state 1. That means it is having some internal energy, that is U1. Now Q amount of heat is applied to the system and the system absorbs the entire amount of heat. There is no loss of heat. So the internal energy will be increased and it will become U1 plus Q. Now W amount of organ is done. So that also it will be on the system. So total internal energy will be increased to U2. So U2 can be written as U1 plus Q plus W. Change in internal energy, that is U2 minus U1, that will be written as del U. So del U equals to U2 minus U1 and that will be Q plus W. That means Q is the algebraic sum of heat transferred between the system and surroundings. W equals to what interaction of the system with the surroundings. Understood? Now change in internal energy equals to heat absorbed by the system plus work interaction. If change of internal energy does not equals to zero in thermodynamics process, the energy must have been transferred into or out of the system in the form of heat or work. Okay, so this is the conclusion from the first law of thermodynamics. Now we will gradually move to enthalpy. So before moving to enthalpy, we should know different thermodynamic process. So what is the role or how first law of thermodynamics is applicable for different thermodynamic processes? Say for example, adiabatic process. Adiabatic process means Q equals to 0. So from first law of thermodynamics, what do we know? Del U equals to Q plus W. If Q equals to 0, then del U equals to W. That means change in internal energy equals to work done exerted by the system. For cyclic process, what will happen? Del U equals to Q plus W. As we know, cyclic process means there is no change in initial and final state. So del U equals to 0. Then what will happen? Q equals to minus W. For PV work done at constant volume, what will happen? Del U equals to Q plus W, Q equals to, and W equals to, we know that equals W equals to minus integration of V1 to V2 P external into dB at constant volume. V equals to 0, so what will dB equals to 0, so what will happen? Del U equals to Q suffix V. That means change in internal energy is equal to the heat absorbed by the system at constant volume. Free expansion for ideal gas. As you know, free expansion means external pressure that is equals to 0. So P external will be 0. So del U equals to Q plus W. Del U equals to Q minus integration V1 to V2 P external into dB. As P external equals to 0, so what will happen? Del U equals to Q. Ideal gas expansion in thermal isothermal mode, what will happen? Value of internal energy is dependent upon temperature. At constant temperature change in internal energy equals to 0. So del U equals to Q plus W. As internal energy equals to 0. So what will happen? 0 equals to Q plus W. Q equals to minus W. So minus Q equals to W. So these are the application of first law for different thermodynamic process. In this slide, here I have not shown in this slide, but all these theories and these things are available at the website of Council, West Bengal State Council website. These things are easily available. Still, if there is any query, you can email me. Now we'll discuss about enthalpy. What is enthalpy? Enthalpy means basically it is the measurement of energy in thermodynamic system. The quantity of enthalpy is equal to the total content of heat of the system equivalent to the system internal energy plus the product of volume and pressure. That means H equals to U plus PV, where H equals to enthalpy of the system, U is the internal energy, P pressure of the system, V is volume of the system. So enthalpy is nothing but the summation of internal energy plus PV work done. So it's basically one type of energy. So this is a state function. That means whenever there is change of enthalpy from state 1 to state 2, it is independent of the path. It depends only upon the state 1 and state 2. This is extensive property. That means mass dependent. So suppose there is a reaction that is A plus B to C plus D. So A plus B, these are known as reactants. C plus D, these are known as products. So change in enthalpy means del H equals to summation of enthalpy for the products minus summation of enthalpy for the reactants. Total enthalpy for the reactant, and which we have to calculate total enthalpy for the reactant molecules and total enthalpy for the product molecules. Change in enthalpy means total enthalpy for the product molecule minus total enthalpy for the reactant molecule. What is the unit of enthalpy? Same as joule or calorie. Enthalpy is a property of thermodynamic system that is a convenient state function preferred in many measurement in chemical, biological and physical system at a constant pressure. So enthalpy, again enthalpy, absolute enthalpy cannot be measured. We can measure the change in enthalpy by bomb calorimeter instrument. So on more information we should know the enthalpy of an ideal gas is independent of its pressure and depends only on its temperature, which correlates to the internal energy. Real gases at common temperatures and pressure often closely approximate its behavior, which simplifies practical thermodynamic design and analysis. However, we have to understand only the ideal gases. We will not discuss anything about real gases in this session. Whenever you will go for higher studies, the concept of real gas will come. There we have different theories. Now it is related to enthalpy, heat of reaction. Already I have told the total enthalpy of a system cannot be measured directly. The enthalpy change of a system, it can be measured. Enthalpy change is defined by the following equation: del H equals to HF minus HI. Already I have discussed these things. Specific enthalpy of a uniform system is defined as small h equals to capital H by m, where m is mass of the system. The SI unit of the specific enthalpy, joule per kilogram. That means total enthalpy divided by the mass of the system. That is called specific enthalpy. So a enthalpy is an extensive property, but specific enthalpy is an intensive property. Okay, so this is all about the heat of reaction and specific enthalpy. Thank you very much for attending the session. Again, I am telling you, if there is any doubt, feel free to email me at sp.fpt.arm@wbscte.ac.in.